Okay, ladies and gentlemen, welcome to the second video covering section 4-4 in your geometry textbook. This video is going to focus in on the side-angle side congruence postulate, which is the second of two postulates discussed in the section. First video we covered the side-side-side congruence postulate. So, in order to introduce side-angle side, we first need to discuss this idea of an included angle. An included angle is an angle formed by two sides of a triangle. So for instance, if we look at angle C down here, angle C is the included angle for sides AC and side BC. Those two sides form angle C, so that makes C the included angle for those two sides. They make that angle up. We could just as easily assign this word to any of the angles in this picture. Angle B is the included angle for sides AB and BC. Those are the two sides that form that angle. So any angle could be an included angle. For instance, angle A is the included angle for those two sides. Included angle for AB and AC. So it's just a matter of what two sides we're talking about. The included angle is the angle that is between two specific sides in a triangle. All right, so this leads us into the side-angle side congruence postulate, which again could be used in a proof. If we use it in a proof, we abbreviate it as SAS. It reads, if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then those triangles must be congruent. In other words, if we have two sets of sides and an included angle, we don't need the rest of the information. Those three specific pieces would be enough to guarantee triangle congruence. So in the picture, you'll notice that we do have two sets of sides. AB is congruent to DE, and BC is congruent to EF. We also have the angle in between those sides. Angle B is congruent to angle E. Because we have two sides and the included angle, that is enough for us to finish this proof and state, or to state that triangle ABC is congruent to triangle DEF, because we've shown this much information, side, angle, side. So I believe next we're going to do a proof of this, or proof involving side, angle, side. So again, every proof that we do starts off the same way. We're going to restate our givens, which are that WX is parallel to YZ, which is already marked in the picture with these black triangles indicating parallel, and that WX is congruent to YZ, which is also already marked in the form of these dash marks. Now, the only reason that they would tell us that two line segments in this picture are parallel is because that would imply that there is a pair of angles that fit one of our transversal vocabulary rules. So in step 2, you'll notice they declared these two angles, WXZ and YZX, as being congruent. If we go to the picture and we find those angles, WXZ would be this angle, and YZX would be this angle. Hopefully we recognize that WX and ZY being parallel makes XZ a transversal and makes those two angles alternate interior angles, meaning that the alternate interior angle theorem would state that they absolutely must be congruent to each other. Because if two parallel lines like XW and YZ are parallel and they're cut by a transversal like XZ, that means each pair of alternate interior angles must be congruent. From there, we need to recognize that these two triangles, WXZ and YZX, share a common side. They have XZ in common. Anytime two triangles contain a side or share a side, there's going to be what's called a reflexive step in our proof. Since they share xz, we can declare that xz is congruent to itself because the reflexive property says every line segment is congruent to itself. So by stating that xz is congruent to xz, we provide ourselves with a second set of congruent sides. Once we have two sets of congruent sides, and notice the included angle between them, we have shown side, angle, side for both triangles. Top triangle, side, angle, side. Bottom triangle, side, angle, side. Which is enough to finish the proof. WXZ is congruent to YZX by side, angle, side congruence postulate. Okay, now the final thing we're going to talk about in this section is the non-proof skill that is key to these two sections, 4.4 and 4.5. That is looking at a picture and its markings and being able to tell which of our theorems and postulates, specifically in this case whether side, side, side or side, angle, side, would apply to that specific picture. So the directions are going to read, determine which postulate can be used to prove that the triangles are congruent. Now notice I forgot to put to prove on your notes, so please write that in there. If it is not possible to prove congruence, we're going to write not possible. So in the first example, we notice that we have three sets of marked sides, 1, 2, 3, which is more than enough information to declare by side, side, side that those triangles must be congruent. In number 2, we only have one marked pair of sides. However, we can guarantee with the reflexive property that this common side is definitely congruent to itself. Unfortunately, that's still only two pieces of information. We have to have at least 3. So that's not enough information, which means that this is an example of not possible. We're going to do the fourth one next, only because the third one requires more explanation than the fourth one. In the fourth one, we have two sets of congruent sides marked. We also have a set of vertical angles, which we are allowed to add to these pictures, vertical angles, and if we have parallel markings, any parallel transversal angles that would come up, we're allowed to mark. So since those angles are vertical, we are allowed to add that to the picture, which is enough information to finish that one off using the side angle side postulate. The third one requires a little bit more explanation. While we do have two sets of sides and one set of angles, you'll notice that that angle is not where it should be. If it was going to be side angle side, it would have to be this angle, the included angle, between the two marked sides. This is angle side side. And there is no such thing as angle side side. This is not possible. And I always make a big deal out of this, okay? There is no such thing, for several obvious reasons, as angle side side congruence, okay? You're not allowed to use that one for several very obvious reasons, okay? The sides have to enclose the angle. The angle has to be formed by the sides in order for side angle side to work. This, it would have to be this angle and this angle. Since it's a non-included angle, that would be SSA or ASS, neither one of which exist. So that is a not possible. I think that does it for 4.4. Yes, it does. That does it for the 4.4 video notes. We're going to go into the 4-5 video notes, which will probably take a significant amount longer to do. Thank you very much for your time.